Okay, today we're going to talk about motion. How can you describe an object's motion? Well, what is motion? Well, if you have a car, you can't tell it's in motion unless you have some sort of reference point. A reference point is like what you're comparing the motion to. So, like when you're on the road and you see a car, you can tell it's moving because it moves past something like a tree or a light post or something. So motion, there has to be a reference point, something that you're comparing the motion to, and there has to be a change in position. So the car is going in some direction. Okay, the position is changing. Change of position. So to have motion, there has to be a reference point and there has to be a change of position of the object that's in motion. Alright, now let's talk about how you can describe that. You can describe it with tools that measure. So you can measure the distance that this car is moving, right? So if the car goes over here and stops, you can measure that distance. You can measure it in centimeters if it's like a Hot Wheels car, or you can measure it in meters if you're walking, or if it's a real car on the road, you can measure that distance in miles. Measure the length of the motion. And another thing that you can measure is the direction. The direction is what we call a vector. Direction. That's known as having a vector. Vectors tell us direction. Okay. Now, when something's moving, of course, you can measure its distance. You can tell what direction it's going in. And that's going to give you something that we call velocity. Velocity is the speed of something with a given direction. So, speed the speed of a cat that walks by could be about, 10 centimeters per second. You could get the ruler out and measure her speed. She's kind of slow. Thank you, Miss Kitty. Speed is the distance the car traveled divided by the time it took to travel. So like when you're talking about a car, of course, usually that is in miles per hour. You're going too fast, the police will let you know. Get a ticket if you're going their speed's too fast. But in a classroom, we're probably not going to measure miles per hour. We might measure maybe centimeters per second. Because, we can get centimeters on the ruler. And we can measure seconds with the stopwatch. So, but notice there's still a distance. Centimeters versus miles. There's distance. And then we have time. Hours and seconds. And could do minutes. You've got two, things to measure. Distance and time. So these are units. Don't forget that. So you can measure the speed of motion, and you can turn that into velocity. Speed with direction. Okay. So if we have something like 30 35 miles per hour, well, that's just speed. But if we add east, now we have direction, and that's velocity. My Hot Wheels car, maybe it moved 12 centimeters per second. That's speed. But if it moved 12 centimeters per second north, that's velocity. Velocity is just speed that has the direction that it's going in. Okay, let's talk about how we can take this information and graph it. Remember last week we talked about graphs and how you have to have certain things. On this graph, we're going to graph time on the x-axis, and remember to always have your units. Let's just put seconds here for now. And we're going to put on the y-axis distance. Put an M there for meters. That would be our units. So, remember when you're making your graphs, you got to have a title. It can't just say the word graph or the word title. The title has to actually give some sort of indication as to what the graph is about. So this graph is about the speed of a car. Remember, speed is distance divided by time. And remember, when you make your numbers on a graph, you need to have your pattern, whether you're counting by 2s, 4s, 5s, 10s, or maybe you're just going to count by 1s. I don't know what you're going to do, but whatever you do, just make sure you consistently stick with that pattern throughout your numbering. Don't just go like from 1, 2, 3 and then go to 6 automatically. You've got to have, a pattern, and you got to stick with it. And then let's say on the distance scale over here, let's say we're going to count by 10s. So when you do a lab, like you're going to do a Hot Wheels lab pretty soon, and you're going to be measuring the speed of a Hot Wheels car, you can take the distance that the car travels and the time that it travels that distance in and plot those points. And then when you do that, you'll end up with a line. And remember, your book talked about this thing called line of best fit. A line of best fit is a line that goes through your data, and it hits some of the numbers, maybe not all the numbers, but the numbers are going to be either on that line or pretty close to that line. Okay? So I tried to draw a straight line and got some of my numbers really close to the line. Usually you would do this when you have more, dots on there, you have more data points. But the line of best fit goes through most of the data. And when you do a line, or when you do a line like this, that tells you there is some sort of relationship between these two things. If you have some sort of graph that you have dots over here, dots over here, dots over here, then you really can't do a line because the data is all over the place, and then you would have to say, well, there's no trend. There is no relationship between these two things because you can't draw a line. Don't assume that you're going to be able to get a line every single time you make a graph. You can only get lines if there's a relationship between these two things. Okay? But in this case, there is a relationship between distance and time because it tells us the speed of the car. And remember, you can calculate the speed by taking the distance, 30, that's like 30, that's like 55. So the distance between this dot here and that dot there, that's 25 meters. I'm just taking where that spot is on the graph, coming over here to see that it's about 55 because it's halfway between the 50 and 60. And this spot here, right here, that's right on the 30. Okay? Then you take a look at the time. This is boom, 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 2 seconds. Come down here, boom, 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 boom. That's 4 seconds. That's a distance or a time difference of 2 seconds. So, the speed of this car is 25 divided by 2, which is 12.5 meters per second. And that's how you can use the slope of a graph to help you figure out the speed of a car. Okay, make sure you take some notes on that. Notice where I got these numbers. I just took 2 spots on the line. Came over here, boom, 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 that's that number. Boom, 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 that's that number. Subtract it. Slope is rise over run. Rise, how much the line rises up. Goes from here to here, that's a rise. Over the run, which is this direction. How from here to here, that's that many seconds of time going by. 2 seconds. But rise over run gives you the slope. And when you have time versus distance, that slope is going to be the speed of whatever object it is you're measuring. Okay, so right now I'm driving 30 miles per hour, just a hair over 30 miles per hour. That's my speed. My velocity would be 30 miles per hour east. Speed with direction. That's velocity. Okay, acceleration now is when you have a change in speed or a change in direction. You can have positive acceleration, negative acceleration, or, a change in direction. So if you see the speed, I'm going about 50 miles per hour right now, and I'm going to come to a stop. So you're going to see the speed come down. Okay? This is negative acceleration. Speed's coming down. Negative acceleration. Okay, now I'm going to change direction. Go in this direction. Now I'm going this direction. That's also acceleration. Now look at the speed. It's going up. My speed is increasing. That is also acceleration. So acceleration is a change in speed, either positive or negative, or a change in direction. So I'll finish up by telling you that in class pretty soon we're going to actually be measuring Hot Wheels. So you'll need to know how to measure centimeters and time with a stopwatch so you can calculate the speed of the Hot Wheels. And then we'll also be talking about energy in class. If you have some Hot Wheels at home and you want to bring them, that would be lovely. See you in class.